Hello and welcome. We're looking at the mechanism of nucleophilic addition to carboxylic acid derivatives. And as we mentioned before, when you have a carboxylic acid derivative, this Y here are different groups and they can be looked at as living groups. So a nucleophile will replace the Y, it will substitute the Y, and you end up with a nucleophile at that position. Okay, now mechanism. The first step in this reaction involves nucleophilic attack on the carbonyl carbon, and then at the same time, one of the double bond electrons breaks off and the electrons flow to oxygen to make O-. Now you end up with a nucleophile added to that position and the minus charge being on oxygen, and you still have the Y connected. Now look at this carbon. This is an sp2 carbon. It's bonded to three things, and then here it changes to an sp3 carbon. So that is an intermediate, and it's called tetrahedral intermediate because that carbon becomes tetrahedral. The next step in the mechanism will involve the minus charge on oxygen flowing back to make a double bond between oxygen and carbon, while at the same time kicking out the living group, which you're using Y in this case. And that will give you this product. So now you have a double bond between oxygen and carbon, and you have the nucleophile occupying the position that originally was occupied by Y. And you have Y as the living group. Thank you very much. If you enjoyed this presentation, please subscribe.